This class, I like us to be talking a lot. It helps us to remember. Hello? Divine. How many messaging applications have you used? Any other messaging application that you can think of besides the common, or just any messaging application that you can think of? Or Leslie, tell us. Tanatswa.
Good morning, ma'am.
Good morning.
It's the usual WhatsApp, Facebook, Instagram. I think mobile apps in this age have reached a stage where most of them can have a messaging feature. Maybe certain APIs that have to do with sending messages. Yeah, that's all I got.
Okay. Anyone else? We need to know that we are together. Okay, if you don't answer me now, I will ask you. Okay, I will force you to answer me one of the days. Anyway, so like I was saying, there are functional requirements. It should be functional, first of all. So there are requirements that you would say these are specific to each and every application. What does the user expect in terms of the system? What's expected? What's reasonable on every application that you're going to develop? Then it should be usable. It should be easy and intuitive for someone to interact with. You don't want an application where you need to give people a tutorial on how to use the application. It's okay maybe if you're developing it for an organization. That's when you're going to have that opportunity. But in most of these applications that you're going to develop, you're probably just going to put them on Play Store. And people should be able to just, download your application and be able to find their way around the application, and not develop an application that is so complicated, because the moment they see it's complicated, they easily drop it because there are so many alternatives on these Play Stores. You know how easy it is to distribute some applications nowadays. So that's the challenge now that you would meet if you don't make it as usable as possible. And then in terms of performance, it should be able to use resources efficiently. You will see, I think it's the next slide that we will talk about the constraints that are associated with mobile devices. Mobile devices have limited resources. If you're to compare it to a laptop or to a desktop machine, you see that there are so many limitations in terms of the memory, in terms of the CPU. So if your application is not able to use resources efficiently, you're going to face challenges. Probably it's going to be too slow. It's going to become unresponsive in some cases. So to avoid that, you need to make sure that you optimize your application as much as possible. And it should also be reliable. stable and secure, that is across devices and platforms. It should be able to work if it's an application that you're putting on the stores. It should be able to work on different platforms or different mobile phones, because we're all going to buy different. There's a wide range of mobile phones that are available. So now it should be able at least to function on almost all. If there are some that maybe it's going to fail, but at least it should be able to work well on most. And it should also be secure. That is, you are encrypting the data when you're transmitting, making sure that you're using the protocols that allow the security for the data that is going to be transmitted. So design now is influenced by both the hardware and the software, that is the operating system of the mobile device and the frameworks that are behind, as well as the limitations of the hardware. Um, okay, I have done it again. Let me see what I should do here. Okay, let me start again. Are you able to see my screen? Hello?
Yes, ma'am.
Hello?
We're able to see the screen.
I Okay, that's fine.
Yes, ma'am.
So, oh, thank you. And it's good to hear a different voice as well. So, we defined an embedded system last time, and I think I will just skip the definition for today. But yeah, like we were saying, it can also be a part of a larger system, or while it is built for a specific purpose, but you can have it attached or being integrated to a larger system. And you find them in many devices in almost every industry nowadays. And it is the embedded systems that you're using to have your street lights changing, to have being able to take pictures of cars as they are running the red robots and stuff like that. I mean, there is a lot of them almost everywhere. If you choose to look closely, you will see them almost every day, even at home as well. So often these systems are performing critical and security related functions and must be developed or designed with great care, because you want them to be always available so that you'll be able to meet the need. What are the key components of an embedded system? There is a processor, that is your usual CPU or the microcontroller unit. And in mobile phones, it's usually the ARM Cortex. And they also have memory, that is the RAM, the ROM, the flash storage. They also have some sensors and peripherals, your GPSs, your accelerometers, and every other peripheral that you're using, or every other external device that you're connecting for input or output. And then the real-time operating systems. This is optional for usually the critical time critical applications. There are some applications that you'd say they really have to pay attention to the time. Can you give me an example of an application that you'd say it's really time critical? Somebody, an application that you've seen that you'd say this one, you really have to pay attention to the timing if you're developing this an application like that. Nasimakane time. Okay, let's say you have a healthcare monitoring system, something that you're using to monitor. Maybe you're monitoring the blood pressure of your grandmother that is somewhere down there. Oh, that is anyway. But you want to make sure that at any time you know how high or how low it is because of probably a certain disease that they're suffering from. So you'd want it to be as real time as possible so that you don't miss it in any way if it goes up or if it goes low. And as an example. So when you're looking at embedded design, what are the characteristics? It's resource constrained. Usually mobile devices or generally embedded systems, they could be internet of things kind of devices, or it could be your mobile phone. They lack the computing power and the memory capacity that maybe the desktop computers or the servers would probably have. So if you're going to develop software for such a system, it should be highly optimized and it should be efficient in such a way that you ensure that they consume as minimal memory and as minimal processing required resources as possible, to the extent that you are able to achieve or to perform the tasks that are required with optimum resource usages. No, nothing extra. Then, in some cases, they require real time performance, but most of them they require real time performance. So you're trying to respond. The system should be able to respond to inputs and events within strict time constraints, because you see that most of them you're using them for monitoring, or if you're looking at a mobile device, you're expecting it to respond as soon as as soon as you touch a certain, maybe a certain button, as soon as you make a swipe, you should expect the change to happen. So you need to design your applications, I mean, with that in mind. So the correctness of operations depends on the logical results that you're getting, but also when the results are also what produced. Of course, you can get results, but what if, just imagine you swipe your phone and you get the response after maybe 10 seconds? Would that be useful? Or I mean, yes, you get the response, you get the results, but if it's not timely, then it changes everything. The same with low power consumption. Most embedded system or most embedded devices are battery powered. They usually have limited power sources. Yes, your mobile phone, you can use it when it's on the AC power supply, but you'd want it to be, because it's portable. You want it to be as mobile as possible. So you expect that the device should consume as little power as possible. And low power consumption is achieved when you have efficient hardware components, you have optimized software algorithms and power management techniques, such as allowing sleep modes when maybe certain applications are not being used. And then that helps you to reduce the power supply, the power consumption, and also prolong the battery life. And then there is also reliability and long-term operation, because you're expecting them to operate continuously without failure. You need to make sure that you're having an embedded system that is reliable, that is quite stable, and that is fault tolerant. As a developer now, you should test your applications well. You should ensure that there is error handling, and there should be redundant mechanisms to ensure the system can function correctly over a very long time. so that you don't have a situation where you have an application that constantly crashes, because there are so many options. People will just leave the application. So you'd want to make sure that it is as robust as possible. Then we also talk of embedded operating systems. These are specialized operating systems that are designed to manage hardware and run applications on embedded systems. Just like the usual operating systems, I think you've done a module on operating systems. And the common embedded operating systems that we talk about in mobile devices are the Android, the iOS, and the real time operating system. And what are the responsibilities of embedded operating systems? There is task scheduling. There will be several tasks that are trying to run on your mobile phone. Now the operating system should be able to determine which task should run, when it should run, and how long. The usual task scheduling that you do with your normal operating system. The same with the resource allocation. You make sure that each resource, each application or task is allocated the necessary resources without. There should be efficient conflict handling as well. Then the device drivers, the OS is using the drivers to manage and to control hardware functionality, to provide the standardized interfaces for your applications, and to interact with hardware components. Then also to do power management, because like we are saying, embedded systems usually they operate on low power because they are battery powered most of the times. The operating system is responsible for enforcing or for implementing sleep modes, dynamic voltage scaling, and shutting down unused components. I think you've seen sometimes your mobile phone will tell you that it is putting some applications to sleep because they have been unused for a long time. I think you've noticed that. All that is meant to try and reduce power usage and extend the battery life as much as possible. Then there's security enforcement in terms of access control, in terms of authentication, in terms of encrypting data, or ensuring that there is secure communication to make sure that integrity and confidentiality of your data is maintained as much as possible. And then we go on to the features of embedded operating systems. They are usually deterministic in terms of the response power. That is, they should operate with it should be predictable, that they should respond to events within a fixed and a guaranteed time limit, because usually tasks in embedded systems are executed according to a strict timing constraint, or there should be a strict timing to every event or to every task that is being performed in an embedded system, so that any critical operation that is happening is processed as fast as possible. Then also they have small footprint. Embedded OS operating systems are designed with a small memory and storage footprint because you want them to operate efficiently on the mobile device or on the embedded system that you already know has limited hardware resources. So it should be able to work with minimal RAM. It should be able to use very little storage space, but also it should be able to provide the essential functions. It should function perfectly, but with minimal resources. Then modular design. So the operating system is designed or is built using separate and independent components or modules, and each module will be performing different tasks, such as maybe networking or device control, um, authentication, or something like that. And that way, you make sure that you include all the necessary modules but at the same time, you also reduce the size of the system. Therefore, at the end, you're improving the efficiency. And it also becomes easier to maintain and update each and every module that is part of the operating system, and even to customize the different embedded applications as well. Now, what are the design constraints of mobile applications? We classify them as either hardware or software. Are we still together?
Yes, ma'am.
Okay. Thank you for the confirmation. You've become very quiet. So the constraints can be either hardware, they can also be, I mean, we can look at them from the angles of being hardware or software. In terms of hardware, we're looking at the limited battery life. We are looking at the processor performance, and we know for sure that they are less powerful comparing to, I mean, the desktop is the basic, or the laptop. I think for you guys, the laptop. And then there are also limits to the memory. But of course, nowadays you will admit that the mobile phones are now able to have as much, maybe as traditionally you were looking at maybe 2 gig to 8 gig, but now you're getting up to 16 gig and probably higher in terms of RAM. And in terms of the storage, the ROM, probably you're getting as much as maybe 256 gigabytes. I don't know if you've used a mobile phone with higher. Anybody? Hello. How much storage the, are your mobile phones having? So that we know when we're talking to you, like, are we
One terabyte.
Oh my God. Really? Which phone is that?
Samsung S26 Ultra.
He's lying, ma'am.
ah, yeah. No, I don't know about that one, but there are limitations in terms of storage capacity and also small screen sizes. Usually, mobile phones are usually probably how many inches? Uh, Maybe we're looking at 7 inches or something like that, um, or something less. So when you're designing, you need to know, like, your user interface should be considerate of that. How are you going to lay out the content such that it fits on the small screen size? And then maybe when you're developing for tablets, also you should also consider like to increase the layout of your content. Then in terms of the network constraints, some of the mobile networks can be unreliable and slow. Yes, they are improving, but there are some areas that are not even perfect in terms of network connection. And also, I mean, there are a lot of constraints that come over around the networking issue. So in terms of software now, there are platform limitations. Usually when you're looking at your Android and your iOS, applications are running in sandbox environments, trying to have each application run as separate as possible to try and ensure security. And then also there are restrictions with the APIs. So those are some of the limitations that you find with these platforms. Then also the App Store policies. The applications must comply with the guidelines. So those are some of the limitations. Those are the challenges that you will face when you're developing for mobile applications. And also the backward compatibility should be able to support older OS versions. even when they are newer, newer OS versions, but there are some that are still using the mobile phone that was developed probably 5 years ago, 10 years ago. Maybe not 10, but some years before. So you should also ensure that when you're building, you should be considerate of that. And then multitasking restrictions, background activities may be limited because, like we were saying, you want to ensure that resources are used as sparingly as possible to ensure the optimal performance of your device. So the chances of trying to limit background activities is really a must. So now when we are architecting mobile applications, this is when you're trying to come up with the high level structure of your software system to ensure scalability, maintainability, and ensure the performance is par. So the common architectural part, we also have the clean architecture, the microservices, and plus APIs for complex and cloud integrated applications. Then we have like the clean architecture for separation of concerns. That is the domain, the data, and the user interface layers. So we look at the MVC. It separates an application into three interconnected components. You have your model. The model is what is managing the application data and the business logic. They have it represents the interface and the mediary between the two. Representing the system. So the separation to achieve code organization of it separately without affecting this, which becomes useful on the part of the developer. Then the model view model, it's quite now common in mobile. The model is handling the data and the business logic. The view, it displays the user interface to the user, and the view model, it's like a bridge between the model and the view, which prepares and manages data for the user interface. So the view model now exposes data in a way that the view can easily consume the data using data binding, testability, and separation of user interface logic from the overall business logic. Then we have the clean architecture. So we're saying you separating concerns into multiple independent layers. You're having a domain layer, a data layer, a user interface layer. The user interface layer is what is managing the user interface and the user interactions. Then the data layer, it's focusing on the data sources that you have. It could be the API, the repositories, or whatever databases that you're having. The domain is looking at your basic rules and your logic, and each layer will now be depending on an inner layer. So that's the clean architecture. Then the microservices, you're saying sometimes you have a complex or a cloud-based application. Now you can have it divided into multiple small and independent services that you're terming microservices, and each one will be performing specific functions. Maybe one is for notification, one is for payments or authentication, or any other functionality that you can think of. And the services are communicating with each other using APIs. And this one now improves scalability and flexibility, easier maintenance as well. And it's usually perfect for the large mobile applications that are cloud hosted. And then the key considerations in architecting mobile applications. So we talk of modular design. We are saying with mobile applications, I think we have mentioned modular design, where we're saying you are separating the modules of your application, and each will be responsible for ensure that it's easy to update, it's easy to modify without affecting so many other components or without having to rewrite the whole mobile application. Then also scalability. Your application should be able to handle an increasing number of users or increasing the data, the transaction, or whatever that the application is doing without reducing the performance. I mean, without degrading the performance of the application. Then offline support, where there is little or no internet connection, such that you can perform several tasks that when you finally back online, you are able to just continue. This you would probably achieve using techniques such as maybe using some caching your data on the local storage that you have on your phone, on your databases. And then you also make use of synchronization techniques when you go back online. I think this is very common, especially with maybe backups of maybe images. I think you've seen it, especially with like maybe Google Photos, or maybe if you have a diary, an online one, or a notebook that you probably enter some stuff, you modify some stuff, then when you go back online, you're able to synchronize. Then cloud backend integration. This is where you're saying some applications are now going to have to be integrated with the cloud or with cloud resources for storage, probably, or for authentication. Some applications are actually depending on the cloud for authentication, and even for secure communications as well. And you should be able to also use secure communication, such as the HTTPS instead of the HTTP, and then the open authentication mechanisms as well, to make sure that your users' data is as secured as much as possible. So that's it with the considerations. Then looking at the user interfaces for mobile applications, go ahead and look at the material design for Android and the human interface guidelines for iOS. This will be helpful, and this can help you to understand the user interface design for mobile applications. Responsiveness should adapt layouts to different screen sizes and orientations. Your application should be, I think nowadays it's not very common, but back then you would see an application that really shows that in it doesn't even fit maybe a certain mobile phone, because it's changing, it's not well architectured to be responsive. But nowadays, of course, it has improved, it has become quite seamless. I mean, you won't even notice the changes from different from one platform to another. Immediate to be given to a user action, and it should be as immediate as possible. Then accessibility, it should design for all users. That is in terms of let's say you're looking at screen reading, you're looking at the contrast, you're looking at the font sizes and stuff like that. It should be considerate of all the different users. Then the user interface components. text fields, some lists, some navigation drawers, some bottom navigation. So a button, I'm wondering whether I should, what is a button? I think this I should not even describe. What is a button? What does it do? And an example. Any volunteer?
I think it creates an action when clicked.
Okay, yes. It creates or triggers an action when clicked. And we find it in many applications, many applications, many stages, or many pages on our applications. For example, you're creating an account, that's what you're going to use to submit. For example, you're deleting, that's what you're going to use to perform the deletion function, or even to open a new screen, or to close a previous one. You're making use of a button. And then a text field, you're using it for inputting data. I think this we can skip some of them, right? You're using text fields for inputting data. You have some lists that you're using also to display much information. Probably, maybe if you're looking at your WhatsApp, a list is what is showing your charts, it's showing your contacts and stuff like that. Then we have the navigation drawers. You're using them as menus that that you can. It's showing you different sections of your application. Just displaying like different sections of your application to the user, so that the user will be able to decide which section they're going to visit. And then we have the dialogues. They are just pop-up windows that are appearing probably on top of a screen that you're having. Maybe you want to close a certain page sometimes, or maybe you want to delete. That you're getting a pop-up window that is asking you whether you want to proceed with that, or you want to cancel it, something like that. The same with the snack bars. They're like brief messages that you're getting at the bottom of the screen. Maybe you've done something and then you probably have deleted, and you're being asked whether you want to undo, or you're fine with it. The same with toasts. They are just a short temporary pop-up messages that are on your screen for a few seconds, probably just updating you that you've successfully maybe submitted a form, so they probably successfully completed a certain task, stuff like that. Those are some of the components that you can have on your user interface. Now we can also talk of touch events and gestures. So mobile applications rely on touch-based inputs instead of the traditional peripherals. I think this is now common, especially with the smartphone. So the common gestures are the tap, where you are using it to select or probably to activate a certain action. You can have, but then you have a single tap, you have a double tape for different functionalities. You can talk of swiping to navigate, probably even to delete same action. The pinching, the long presses, the dragging, and the dropping. I think we should have read, not having a class for it. Then, how do you handle the touch events? On Android, we have a class that is called on touch event, and this one It just detects some tap gestures that you'll be doing or that you'll be performing on your mobile phone. And you also have the gesture detector, which is basically recognizing every gesture that you're making. It could be swiping, maybe you're swiping up or swiping left or right. I mean, for different functionalities, probably for navigation. And then you have for iOS, you have the tap gesture recognizer plus and the UI swipe gesture recognizer. It's just the same, trying to recognize the gestures that you're performing. I mean, that you're making. The different gestures that we were talking about previously, like the dropping, the tapping, the swiping, the long presses and stuff like that. But now the challenges that come with this, like the multi-touch support, you see that because some of them are almost similar. So you see that sometimes there could be conflicts that come with the several touches that you're making to your phone. So you should be able to, I mean, managing those touching gestures or activities becomes a bit complicated. It's something that you really need to handle with care as the developer. The same with the gestures. There could be also conflicts in terms of some of the gestures probably overlapping when you're swiping. Can you think of one gesture that you would, some maybe two gestures that you would say probably they can make a conflict or they could interfere with each other? Hello, are we still together? Oh, you're there. One example would be maybe you're swiping and scrolling. There's a possibility of conflict in such a case. Then also responsiveness of your user interface during interaction. You should make sure that your applications are quite smooth in terms of responsiveness as the user is using those touch events. Then we move on to achieving quality constraints. How do you ensure that you achieve a quality mobile application or you develop a quality application? You have to pay attention to multiple non-functional requirements. Like, for example, you're looking at the performance. The performance of your application matters a lot, in that you should make sure that you optimize your memory usage and the CPU cycles. You should always avoid unnecessary background tasks, like we were saying. If it's not really necessary for the specific task or for the application that is working, then it should be stopped. And you should also make sure you make use of maybe caching and lazy loading. You don't have to load everything immediately. If it's not in use, that's when you probably would go for lazy loading. Probably delay loading some parts of the application. Maybe let's say it's a page. Maybe when one opens a page, you don't need to probably have everything loaded all at once unless it is needed immediately. Then looking at usability, it should be something that is easy for a user to recognize what to do when they open your application. There should be consistent navigation, not for it to change probably with different sections. And it should also, your application should also have fast response to the user for whatever functionality that they are working on or that they are looking at. Then in terms of security, data should be stored securely. That is, you can make use of encryption. In terms of communication, ensure that when you're transmitting the data, when data is being transmitted, it is secured. Make use of protocols such as, the cryptography protocol, such as the TSLs, the secure circuits layer, to ensure that your data is secured when you're transmitting it from one point to another. Ensure proper authentication also is implemented, because you don't want issues of data being stolen. And also avoid hard-coded credentials. I know this is very common with our applications when we are developing, especially for our projects. We probably want it to be as easy as possible, so sometimes we hard code, but in terms of security, it is not secure at all. Then availability, it should be able to handle network failures gracefully, not to just have an application that that fails often. There should be offline support, and also it should be crash free, and